Hello students, welcome to this module number 4. We are going to discuss about pure substance chapter. Okay, let us what is the problem of this kind in the chapter for pure substance. We look over here and see is a problem like this. A rigid container is filled with a steam at a 600 kilopascal and 200 degrees centigrade. At what temperature the steam begins to condense when it is cooled? Determine the corresponding pressures. Okay, so there is a problem like this. A rigid container will be there and it is filled with the steam at a pressure of 600 kilopascal and 200 degrees centigrade. So at what temperature the steam is going to begin to condensate when it is cooled? So determine the corresponding pressure. That is the question. So in the problem, both pressure and temperature is given. Only we have to find out the volume from the steam table. So corresponding to 600 kilopascal, okay, or we can say 6 bar pressure. So we can find out these values. That is V1 is equal to 0.35202 meter cube per kg. So the volume is constant because as the rigid container is there, there is a constant in volume though. So Vg2 is equals to V1, that is the 0.35202, that is the V1. So corresponding to this Vg2 we can find out from the steam table, that is 0.35202 from the steam table is T2 is 154 degrees centigrade and P2 is 2525 kilopascal. So this is the case. The steam begins to condense when the temperature reaches 154 degrees centigrade and the pressure is reaches 525 kilopascal. So this is how we can find out the values from the steam table and you can give the conclusion about this problem. Okay, so this is the pressure what we found here from the steam table. Okay, 525 kilopascal and 154 degrees centigrade. Okay, so we'll look over in the next problem, one more problem from related to this. Okay. Okay, so this is the problem number 5 in the same chapter we are going to discuss now. Here so problem is like this. A rigid tank contains 3 kg of water at a saturated liquid vapor mixture at 80 degrees centigrade. If 2 kg of water is in liquid form, so determine the partial pressure of the mixture and the volume of the tank. So this question is very quite interesting. See why? Because there is one container is there. In that container, rigid tank is there. In that 3 kg of water is going to be water is there. That is at one is a saturated liquid vapor mixture at 80 degrees centigrade. And if the 2 kg of water is in liquid form, so then we have to determine the partial pressure of that mixture as well as the volume. So that we are going to find out now, and also we have to find out the volume of the tank also we have to find out. See, when the mixture is going to be saturated or liquid and vapor, all are coexist in equilibrium, then we can write it as the total pressure is equal to saturation pressure, because since this mixture is saturated in a liquid form as well vapor form and it also coexist in equilibrium, we can write it as total pressure is equal to the saturation pressure. So corresponding to the 80 degrees centigrade, okay, from the steam table you can note down all these values. Okay, from 80 degrees centigrade that is the saturation pressure, that is 47.39 kilopascal. Okay, and the volume of this particular fluid water, that is 0.001029 meter cube per kg, and Vg is the volume of the steam, specific volume of the steam, that is 3.407 meter cube per kg. So these all values we can observe from the steam table corresponding to this particular pressure, that is the temperature 80 degrees centigrade. So this is the partial pressure we can found here, that is 47.39 kilopascal. Once if you know this and we can calculate also the volume, total volume. So total volume is of this tank is like this. That is volume of the water portion plus volume of the vapor. So there is a total quantity of the mixture is 3 kg, and here the volume of the water portion is 2 kg. Okay, and so the mass of the water portion is 2 kg, and remaining is 1 kg of this vapor will be there. So that what we have to do, considering this mass as 2 kg for the water portion, and remaining 1 kg is the vapor portion. So now you are going to multiply of this thing with volume, that is 2 into mf into vf plus mg into vg. So here 2 kg mass is there and vf is 0.001029 plus 1 is the gases, that is the vapor form, 1 kg into 3.407. So after multiplying this value, you may get a 3. That is 409 meter cube. See, this is the volume of the tank, where it is consist of 3.3 kg of water at saturated liquid as well as vapor mixture. So that contains of 3.409 meter cube. So this is the total volume of that tank. Okay, so in this tank there is the problem where you can solve. Suppose they asked to in industry, what happened, most of the industry they are storage of steam, or sometime it is required, what is the capacity of the steam it is going to be stored, or it will be contained. So in that case they may give the partial pressure. We must that time you must able to find out the volume. If they give only temperature of the steam, so we have to find out the pressure as well as volume. So this is the case, we can solve a problem like this. So I hope you understood problem of solving this kind problem by looking at this steam table. Okay, so some other relevant topic related to this problem we can discuss in some next videos. So I hope you understood this problem. Thanks for watching this video.